The video you're about to watch has been made possible by KiwiCo, which is an awesome company I will tell you about later, but for right now, let's get into the wiring. Hey everybody, Adam Savage here in my cave with a tool tip, hoping to demystify wiring. I don't know about you, but when I first started making stuff, LEDs were a mystery to me. This is an LED, a light emitting diode. It uses quantum mechanics to generate light, and they keep us awake all over the world, sticking out of our VCRs and our electronics. But I found these a mystery. You can get them to operate at different brightnesses by adding resistors, and I know there's a formula, and I know it's just math, but I have never learned it. And I think I'm pretty common. I think the way I used to think about electronics was, oh, it's this big black box, and you got to learn how to solder, and you got to learn how to do a bunch of math about resistor codes, etc. And it's sure, the answer is, yeah, being able to wire something up does include all of those things. However, over the years, I have cobbled together my own sort of very simple, straightforward workaday approach to wiring things, and it works really darn well. And I'd like to walk you through it. And I'm not going to use any solder in this build. I am going to introduce you to my non-soldering techniques that I like. I frequently now don't solder until a build is almost done. Like, I'll work out all the wiring problems using the methods I'm about to use, and once I have it all solved, then I will make a wiring harness and solder and use heat shrink tubing, etc. But I don't do that usually until the very end. So let's talk about electronics and wiring function into your costume, because that's how I'm framing this. As my base, I'm going to use a Bill Duran foam helmet, and we have this blank, and I'm going to use this as the blank for my build. I'm going to put a spinny light on top of it, because that makes me smile. I am going to put a fan on the side of it, because a fan is a really important part of a lot of costumes. I don't know what this fan is doing. It's blowing smoke away from you. It's unimportant what it's doing. What's important is that it's going to come up. And then I'm going to put a bunch of these amber LEDs around here. What I want to tell you is, yes, electronics can potentially include a lot of math, but you can also buy a lot of stuff that's all set for the same voltage and only use that voltage. For instance, LEDs can now be bought super bright with the resistor already wired in. So it has these two leads, and all you need to do is hook it up to 12 volts, or I think the other kind is 5 volts, which is what standard comes out of a USB. And this is how I do most of my operations. I buy pre-wired LEDs because it saves me time and energy, and I don't have to think about it. So we have these LEDs I'm going to put across the front here. And that means I have three different systems, three different pieces of electrical, what do you call it? This is where I have three different electrical items I want to power. And I'm going to use 3 switches to do that. And I thought it would be reasonable to start up front demystifying switches just a little bit, because switches are a whole world into and of themselves. For instance, you have things like push button switches, which are also called momentary switches, and both of their names describe precisely what's happening. A momentary electrical connection. It is a push button. There are push button switches that are not momentary. They're called latching push button switches. And just as this one, it stays in when it's connected, and it comes out when it's not. Any switch with a lever like this is often called a toggle switch. This switch is called a rocker switch. You see, their names are all very descriptive. But what about the leads coming out of the bottom of these? Why does this one only have 2 leads and this one have 6? Why does this one have 3? I'm about to tell you. Different switches do different things. The simplest switch is called a single pole single throw. Single throw means it only moves from one position to another. And single pull means moving it from one position to another changes only one thing. That is, these two leads get connected when the switch is down here, and they get disconnected when it's up here. That's it. The three leads on the bottom of this switch make it a single throw, double pull. So it still only moves from one position to another, but instead of just two leads coming out, there's three. And that means that I can have one thing on when the switch is like this, or I can have a second or different thing on when the switch is like that. The way you'd wire this up is that I believe your ground would go to the middle and your two hot leads would go to the outside edge. Single pull, double throw. This means it can do two different things, and it can't do them simultaneously. It can only do one or the other. Then we end up with 6 leads at the bottom of this, and the switch has 3 positions. So that is a double throw, I think triple pull. Basically what this switch is most likely wired to be is that the 2 leads in the middle are 2 separate ground leads. And it can, just like the 3 positions, the 3 pull switch, it can light one thing over here or one thing over here, but not both at the same time. However, because it's got 2 sets of leads, I can run 2 separate types of power through this. I can run 5 volts through this side and 12 volts through this side. Holy hell, when I discovered this, it changed my life. I'm using 5 volts and 12 volts repeatedly throughout this video because it's a USB power and 12 volts is standard automotive. And those are the 2 voltages at which they're the most common and widest array of things for you to wire to. Frequently, when you buy a switch like this, it comes with a descriptive diagram of exactly which leads are latching as you move the switch. And again, lots of switches are single pulls. This rocker, single pull, single throw. This one is a single pull, single throw, except it's got an extra lead to light up the tip. I kind of really like that one. I bought a whole bunch of them surplus a few years ago and I'm still using them. One other kind of switch you should know about is this. This is called a micro switch. It uses this long arm to latch. Your refrigerator uses something like this to stay closed. These are weirdly useful. I found these on eBay. They're made in the great country of China, which means they're fairly inexpensive. What I love about micro switches like this is that I can actually bend this arm so I can make it a door close and I can adjust this arm to fit the space it needs to in order to do the latching that I want it to do. Micro switches are fantastic for door opening activations. And they make these, specifically this is called a micro switch, they make them so tiny it would make your head spin. I have some really, really small ones. They tend to be very expensive. If you find a bunch in a bin at a garage sale, you should just buy them. That is how I began building my collection of micro switches. Okay, that is a little bit of demystification of switches. Let's talk about wiring up 1, 2, 3, 4, 5, 6, 7, 8 LEDs plus a spinny light plus a fan through 3 different switches. It begins with a piece of paper. So every wiring job I do begins with a diagram, and so should yours. A diagram, I've built my whole life holding complicated arrangements in my head, and wiring is the limit of my intellectual ability. I have to write it down, and I have to keep referring to what I've written down. And when I write it down and I have a diagram, I'm working on a project right now. This is the wiring diagram. As I wired in each thing, I colored it in red. It worked on the first try. I couldn't believe it. I'm as surprised as you are. So let's make a wiring diagram for our fan, LEDs, and spinny light. Let's see, the first thing I always draw is the battery, and I label it BAT. And I give it a positive lead, and I give it a negative lead. Then, let's say I do my LED lights. So I'm gonna start in pencil because I might make mistakes. So let's do 1, 2, 3, 4, 5, 6, 7, 8, and we do 2 leads coming out of each of these. These are the LEDs. Fan, plus, minus, plus is always on the right. Plus, it's not always on the right. I'm saying for my drawing, it's always on the right. So there's the fan, there's the LEDs, oh, spinny light. And again, I just usually draw versions of what I have, and it makes it really easy. Here's a positive lead and here's a negative lead. Okay. Oh, right. And then there's, yeah, I just want one switch for each one. Actually, no, I want a master power switch. Okay, so switches have a specific way to draw them, and I draw them in my, that's a switch. I think it's pretty close to how an electrician would draw a switch. So I'm gonna have 4 switches on this one. So I'll draw 2, 3, and 4. And I will label these master. That's the, master power switch. LEDs, fan, spinny light. Yeah, let me, I can draw this in too now. Yep, fan. All right. Now what do? Now I just start adding wires where I know they go. From the battery, I know that the power I'm going to be interrupting is the positive lead. So I know my battery, the first thing it does is it comes over and goes to my master power switch. The master power switch then bridges to the LEDs, but it has a secondary connection to the fan and a tertiary connection to the spinny lights. So what this means now is I've got a hot lead that comes here, and this switch controls that hot lead totally. Then that hot lead gets fed out of that to the LEDs, but it also gets bridged off to the fan and to the spinny lights. Okay, now with the LEDs, this should be pretty straightforward. I move this up, I take this lead from the LEDs, when that switch is latched, this becomes hot, and this comes over to the right side of my first LED. Sorry, the left side of my first LED, let's say that's the positive side. How do I light up all of these? Well, I have a choice. I can wire them in either what's called parallel or series. Please also refer to other people's videos about specific wiring questions you might have. I am a dilettante sharing my dilettante's level of knowledge in hopes that the weird way I've figured out how to parse this will help you. But don't consider this like any kind of canon advice. So you can wire multiple things in what's called series or parallel. And those terms are perfectly descriptive. In series, I would wire them up like this. Hot lead goes into the LED, negative comes out, hot comes from that, goes there. So I'm basically daisy chaining them together with each successive hot lead on the negative lead output of the other. The issue with this is I get a voltage drop across all of them. So they're all drawing, they'll all be a little bit dimmer. If I want them all to get the full brightness out of 12 volts, I wire all of their leads together, and that's called parallel. And frankly, I can't remember the last time I wired something up in series. Your Christmas lights are wired up in series. That's how those little tiny bulbs can take house power and light up. Parallel is way more the way I do things around here. So that's what I'm gonna do with these guys. I am going to take the left leads of each one and basically this is my way of drawing that they all connect up to the hot leg. But where does their negative leg go? You know what, let me get a blue pen and show you that. This is a messy wiring diagram. I'm sorry that it's messy. There are more elegant ways to draw this, and I'll tell you the truth. This was the third drawing I made to get this right. This was the first one. My first drawing is just to wrap my head around the problem of illustrating it, and then when I want to be really clear about it, like I would probably draw my LEDs in a different way, then I make sense of that. So these negative leads come and they go right to the negative lead of the battery. When you want to cross in a drawing one wire over another, you give it a little half step. You give it this little like half circle step. And I'm basically going to do that here. I know this is really messy, and I recognize that it could be neater, but that is not going to be the drawing I do today. And yep, I drew the wrong wire on that one. I agree. I see what I did. So then these all chain together, just like these did, and come out to the negative lead. So there's the LEDs lit. There's two switches that have to be turned on to turn on the LEDs, the master and the LED switch. Okay, now we move on to the fan, and I think you can see that this is going to be a lot simpler. Out of the fan lead, I come up and over to the hot lead of the fan. Out of the fan, I simply come all the way across to the negative lead. Same thing with the spinny light. I come all the way across, and I can connect right there. I can connect this to any part of the chain that's heading back to the ground. And for the spinny light, here we go. That's my wiring diagram. I can't tell you how useful this is, just to have this. And frankly, if I was doing this as a project, I would sit right down and redraw this so it was a little bit clearer for me. But just having this means that when one of these things doesn't work, I can actually refer to the diagram. Oh, I got something wrong, or I can trace it using the diagram. Seriously, this is both a map of how to get there and a map of where you went at the same time. So now that I have my wiring diagram, let's wire up some lights. As I said in the beginning, this video was brought to you by KiwiCo. KiwiCo is a company that hopes to change the future of play by making it engaging, enriching, educational, and also seriously fun. They make building kits for kids of all ages that introduce them to the concepts of STEAM, science, technology, engineering, arts, and math. And they have 8 different subscription lines that each cater to different age groups and topics. One of my favorite things about KiwiCo kits is that they contain everything you need in the box to build what the box needs to build. There's no hunting around your house for a piece of Scotch tape or a paper cup or a rubber ball. If it's in the kit, it's in the kit. I have built several of KiwiCo's kits, and I have consistently found the experience super rewarding. Easy, simple to understand, kid-friendly instructions, even on the complex builds, and the final thing you end up with is genuinely fun to play with. Plus, if you sign up for KiwiCo through Tested, you can get 50% off your first crate on any subscription by signing in through kiwico.com/tested. Okay, there's something I've been doing in this video so far that I'm sure you have done too. And that is to hold up the leads of my power and to actually hold it to the leads of the thing I want to power in order to test operation. First of all, you can only do this with low DC voltages. You should never do this with house power, obviously. And if you're, don't do that. I mean, sure, of course we're all going to do that because it's efficient, but what I really want to tell you is you want some of these Alligator clip leads. You almost can't have too many in your shop. I have a couple of dozen and I use them constantly. So what these do is they give me the ability to connect that to that and this to that, and now I don't have to sit there and hold it with my dumb fingers. And here comes the negative lead, and I can connect it up to the negative lead, and now I've got the item powered, and I can actually look at it, and I'm not sitting there with both of my hands out of operation. Get yourself some clip leads. They're the first step to quality wiring, and if you have a couple of dozen, I've mocked up entire circuits just using clip leads before I started soldering things. Before we start to wiring this up, I would like to discuss where the power comes from. Because, well, over the past period of time, there's a lot more of these power banks on the market. And we'll include a link to one of these in the comments below. This is the one I bought for my USB-powered soldering iron when I first got it. But it's also become sort of my general purpose shop 12-volt supply. I keep it charged, and this thing lasts forever. I can run a costume on this for hours. This one in particular is only 12 amp hours, 12,000 milliamp hours. I don't mean it'll run 1 amp for a solid hour, which means if you're running a lot less than that, you can multiply that. That's part of the electronics math. Just suffice to say that these fat pack lithium ion battery packs that have a USB out and a 12-volt out are a godsend for my shop. And I've got about a dozen of them at any given moment. What I usually purchase are the 12-volt leads that you can buy, this standard 12-volt connector. And yeah, I think we can include a link in the comments below. So I plug it in, and this becomes my main output for testing my circuit. There's a second thing that you can do, which is to get a power supply. And I had one. I had this one, which for some reason isn't working. So I'm going to use my really old one that does work. And this is one that was built by, this is this part of the video where I'm taking a tangent to show you something really remarkable, which is this beautiful object that is one of the camera department's balanced power supplies from Industrial Light and Magic's model shop. When we would have lights on a miniature set, they would often be of many different voltages, and we would connect them up, 4 volts, 6 volts, 12 volts, 24 volts, and then we'd light up a set and we'd take it out to the sound stage and we'd light up the set on the sound stage. Well, they're filming on that set, sometimes in stop motion animation or motion control shots that might last for days. So every night they go home, they turn the lights off. When they turn them on in the morning, they have to be exactly where they were. Not close, they have to be exactly where they were or the shot is ruined. So ILM's camera department built a whole bunch of these balanced power supply. So you could set their voltage with this dial here, and then you'd basically put tape and say, don't touch this damn thing. And every morning you come in and turn on the main light supply, and all your lights would go to the same brightness. Look at this magnificently beautiful thing. It is anodized aluminum, hand machined. I was able to purchase this when a Disney production called The Cinderbiters shut down. They had bought much of ILM's old model shop, and I bought a few of these power supplies from them. Okay. So this is the other way in which I iterate using a power supply. So I will just hook up into this power supply a couple of banana plug leads, and then I get to use alligator clips built right into the alligator leads for powering up my build. So that's what I'm going to do here. Ooh. Before I start adding the wiring, I do the install. Or I do the temporary install, simply because that helps me know how long wires should be, etc. And this one, yep, that's the other one. Just gonna throw a little bit of a nut on there. So, spinny lights are in with their leads coming out. Now, I'm gonna make some holes for LEDs. 1, 2, 3. I'm gonna do 6, because I'm already tired. 4, 5, and I guess I can do the other one all at the same time. Go. Okay, there's my 6 LEDs. It's not pretty. And here comes the fan. The fan will sit here. Another thing that is an invaluable tool for wiring is a wire stripper tool. There are many ways to do wire stripping. The most common is this way. And I'm sure you've seen something like this. You put this around the wire. First of all, you cut, and then you put it on one of the settings, and you peel off the insulation, and that's great. These work great. The thing I don't like about them is when I have a space that is confined and I've got to get myself in there and I'm doing this kind of work like this, and then I'm doing this like pulling, like, right there. I have destroyed so many props over the years just by that action of like, and then I accidentally yank something over here. What is the solution? The solution is this, automatic wire strippers. And we did a video about these a while back. There's a link in the comments. Here's what these do. Change your life. Yeah, that's maybe one of my favorite tools in the whole shop. So I've got the fan. I've got the LED lights. Okay, so now I want to make the switch bank. So I've got here a piece of aluminum with some holes in it, and I'm just going to install some switches into those holes. Switches often have 2 hex nuts on them, and those are meant for being able to set the depth of the switch to where you want it to be, with the goal of the ideal depth is kind of flush with your control panel. I rarely worry about that. I usually just use these as is and tighten them down with my hands. There you go. So I'm going to put 3 of these in here. I once bought a whole bunch of super cheap switches from eBay, and the part about them that was super cheap was the hex nuts on the shaft. Tightening those even a little bit would cause them to split. Oh my goodness. This is when I discovered that you can buy on Amazon really nice hex nuts for switches, and I bought 100 and I haven't had that problem since. Okay, so I've got my switch bank. I've got my helmet with all the stuff that I need on it, and I've got all my exposed wires. How am I going to start connecting all this stuff together? Well, that's where the wiring diagram comes in. First up, I want to wire these guys in parallel, and I'll show you like the most basic. If you really wanted to do this right, what you would do is you would actually expose a wire and run a jumper across all of these right in situ. That's absolutely the lowest profile way to do that. The cheap and fast way to do it is simply to expose a bunch of the wires, expose the ends of the wires, and connect all the reds together and connect all the blacks together. And that is what I'm going to do now on this video. Okay, so now we're going to strip these. 1, 2, 8, 9, 10 and 11 and 12 are all done. Great. So, and again, this is not to show you how to professionally wire your costume. This is to show you how to do it like I learned how to do it, just by catch as catch can, and to demystify the process so that you can try it and learn more about it. That's how this whole thing works. You build up your courage to try something you weren't really comfortable with, and it works, and then you do something more complicated. That's how I've kind of built my entire skill base over the years. So now let's get the red wires together. 6. So I have all these leads together. How do I join them? Well, sure, you can solder them all, but what if you're lazy and impatient, or time is of the essence, and you got to get them together quickly? I'm going to show you how to get them together with a thing called a wire nut. That's what this is called, and it is literally a nut for screwing wires together. It has a little tapered spring, a conical spring inside, and so as I twist it, the wires start to get caught up in that spring, and as I twist it down, it crushes them together, creating a kind of its own thread out of the copper in the wires, and I forgot one of the reds. Hold on. That's the other thing that's great about wire nuts, is that you can undo them to add more pieces to them. They come in many different sizes. If you're going to get some, you should get a bunch. The smallest ones, which are the ones I use most often, are these bad boys. And I'll use this for several of these connections. These little tiny gray ones are the smallest ones. Okay, so I need one more wire nut. For any system I might have to take apart, I love wire nuts. I use them way more than most people I know. So it's definitely a personal choice of mine. Okay, now I've got my switch bank and my wire nuts wired up. Now it's time to bring in some of my extra wire. I love this red and black speaker wire. I buy it in different grades on Amazon. Nothing I'm powering here is too power intensive. So this wire, which is just, no, I don't think this is this wire. I think this is like a 20 gauge. It's not a 22. Yeah, it's probably a 20 gauge wire. And I like the red and black because it helps me, and I maintain fidelity to the red and black, to hot and cold. So what I'm gonna do now is I'm going to run leads from each of these 3 pieces, the spinny light, the fan, and the LEDs, using 3 different wires. So I'm gonna cut these. I'm gonna cut 3 lengths. And let's just clear some wires off of there. So I do a lot of this just prepping wire that I'm about to use. If I want to shorten it later, I do. That's 1. I'm giving you exactly my first attempt at wiring at everything that I'm working on that's electronic here in the shop. This is absolutely how I test little systems and try stuff out. This is how I prototype with electronics in here. No, I have not yet dipped in myself to Arduino or Raspberry Pi, although I have used them in builds. It's usually been under the tutelage of someone else. Okay, how do I connect up this to these? Well, actually on that front, I would clear a little more wire from the end of the lead, and I would bring each one of these up into the arrangement with the big wire nut. Now again, there are all sorts of different ways to do this. You can connect these all up, like I said, to a bus bar. This is just one quick and dirty technique for getting this job done. There we go. I put the wire there, and then I just put the wire nut back on and twist it, and it's gathering it all together. Now, there is one thing I'm going to do here, which I regularly do in the shop, which is now I've got this arrangement. I don't want that to fall apart, so I'm going to add a zip tie. I'm going to add a zip tie here for a little bit of strain relief, and that just makes sure that the wire nuts aren't doing all of the work in holding this thing together. So now I have all the LEDs together, and their leads are coming out here. Hey, let's do a systems check and make sure that they all light up. And here's hoping that they do. 12 volts. If I've gotten this right, these will all light up. Hey! And they all light up! Success! Excellent. Okay, so that system's working. Let's double check and make sure that the spinny light system works. Black lead, red lead. Yep. And let's do the same on the fan just before I clip and clip. Excellent. Oh, right. I said I was going to have 4 switches, not 3. So let's do that. Let's put in this one. This is the master power switch. Okay. We're now in the final stage of wiring, and I'm going to put away my power supply in favor of my battery. The hot lead, remember, the hot lead goes right to the master switch. How does it do that? Ooh, with another technology that I love that uses no solder, and that is wire lugs. These are wire lugs. This is a wire lug that's specifically a spade connector that can connect to the end of a switch like that. And the way you attach it to wire, there are multiple versions, but the most common is that you would put it into the hole and use a crimping tool like this to put a crimp in the end, and that holds the wire in, and that is now a hot lead with a spade connecting female spade connector, right? That's the male, that's the female. I don't think I need to get more descriptive than that. And then this guy stays out in the breeze. Okay, so power, yep. So here's the interesting thing about ground. The interesting thing about ground is that while the power gets distributed out to each of these switches in turn by master power, oh, right, yeah, actually, I messed that up. I still need to do this jumper. I'm going to refer to the diagram. It goes to the master switch and comes out the other side, right, and then bridges to one end of the lead of all 3 of these switches, right. So yes, I need to make a little set of bridge wires that go here. And I'm going to do that using 4 of these lugs. 1, 2, 3, 4. I'm going to cut 4 little lengths of wire, and this is going to be really neat. I'm going to use the red wire only because this is a hot lead. So the first one is that long. Second one is that long. Third one is, yep, the same. Come on. And one last one. Great. So I will clear away some wire on these guys. 1. See, I was getting my brain in a muddle trying to figure out how to wire this, and I just looked at the diagram and it becomes really clear because I've already drawn it out. That's how quickly, like, the complexity of wiring bends my noggin. Okay, so let's say there are many ways, there are many crimpers. This is a fairly expensive crimper, and I like it. I've been using them long enough. So this goes, right, there's only one on this one. great. So that's one. Then on the second one, I put 2 jumpers because I'm jumping from one to the next one. So I'm twisting those leads together, putting them inside. Going to do the same thing on the next one. I am so sure there are all these ways in which I'm doing this in a dumb way. And your comments are greatly appreciated, but you know, I'm just doing it the way I figured it out. Now I connect, right, that's, yeah. So power comes in there and comes out here and goes switch number 1, switch number 2, switch number 3. There we go. So power's coming in and going to all these 3 switches. Now what comes out of these 3 switches? Well, coming out of one, here comes the LEDs. I think that should be our first one, so that's this one. I put on another wire lug. Yep. And bingo, there's the LED's hot lead is hooked up. All right, now it's the fan. Where's my fan? And put that there. I have no power hooked up to this yet. The battery is not connected, so I'm not in danger of shorting anything. And then the third one is the spinning light, which is this guy. And I'm going to need an extension on that. So I'm going to make one. I'm going to make one using this little wire nut, and I'm going to put a lug at the other end. And wire lug sets are really cheap on Amazon, on anywhere. And I know there are probably better brands and worse brands, but I can't tell. So spinning light, there we go. So that is all the switches for the hot leads. What happens to the negative leads, if you remember, the negative lead connects right up using a wire nut to the negative lead on my LEDs, for instance. No, actually it goes to the fan first. Yes, it goes to the fan first. No, we'll just cut this here. And here's the fan. And those connect. Oh, wait, and I need another one that's going to come out of there because I'm going to jump that all the way over to the LEDs. Yep. So I'm going to join those 3 wires with a wire nut. And here comes the jumper out of there. And when I connect that up to this one, we should have a completed wiring system. Okay. And I know this, wait a second, what have I forgotten? I have forgotten to jump the last lead from the LEDs to the battery. So let me get one more jumper. That's the LEDs. And we do one more jumper here from there back to the power from the battery. And yeah, I've got plenty of wire lead coming out of there. This is the moment where it's easiest to release the mysterious blue smoke that makes all electronics work. And if you do that, they'll just stop working because it's the stuff that makes all the electronics work. I tend not to turn a circuit like this on right away. I clean up around it, I take a look, and then I simply walk through the wiring diagram again. Okay, I've got my power. My hot lead from power goes to the master switch. It then jumps from that to the LEDs, the fan, and the spinning light. And the other side of those switches come out and go to the LEDs, to the fan, and to the spinning lights. And the other side of those 3 leads comes off and jumps together and connects back up to the main power. Okay. I feel confident that I have a reasonable wiring system, so let's try it out. Wait, just give me 1 second, shall we? Moment of truth. Here we go. Remember, this is what's going on here. And I don't know about you, but I have a much easier time parsing and working my way through this than this. This makes my brain hurt. I always have to have one of these. All right, let's plug it in. All right, battery is hot. So, I'm not sure what Okay. LEDs are lit. Hey, the LEDs are lit. So then this should light up the fan, which it does not. And then this should light up the spinning light, which it does not. It was this dumb switch. Sorry, this switch this is like some automotive switch and it's got some circuitry in it and it was messing me up, so hold on a sec. I'm gonna use one of the same switches again. I really was wondering if I hadn't done some massive brain fart, and then I was thinking, am I gonna have to shoot this whole thing again? Because I was really dumb on it. And given that like being dumb on camera is kind of my brand, not dumb, but like, you know, unknowing, am I gonna have to show me drawing the wrong wiring diagram for this whole time? Well, we'll see. New master switch, master power is off, now it's on. LEDs, success! And they're brighter than they were before. I don't know what it is with this switch, but. So next thing that should light up is the fan. Light up, you know what I mean. Success! And the last one is the spinning light. Oh, did you hear the fan drop? That's the voltage drop from running this motor. Because I basically have all of these things wired in parallel. And yeah, they're all drawing a certain amount of power. You can see this thing changes its speed. And the master switch turns it all off and all on. Right? Sorry. There we go. That's it. I don't want to say it's wiring 101. It's more like how to think about wiring 101. I know that there are like really specific industry specific ways to do all of this stuff, but I also know that we all do a lot of self-gatekeeping. I hate gatekeeping wherever I find it, but it is most pernicious within our own heads. One of the dumbest thoughts that's ever crossed my brain pan was I was 18 and I was looking at my friend Craig's welded steel sculpture and thinking to myself, welding, pff, there's a skill I'm never gonna have time to learn. Like, from the vantage point of this many years later, like that is crazy. That is crazy. I was doing gatekeeping against something I didn't even know how to do. So if you think of wiring as something that like you just can't do or you just don't know enough to put into a costume, I'm hoping this video helped get you across the line to being willing to try it because it's easier than you think. And don't let anyone tell you different. Thank you guys for joining me for this tool tip. I hope it was useful. And as always, I'll see you next time. I can't believe we didn't finish the video with me wearing this ridiculous helmet, but here I'm going to try. What could possibly go wrong putting all these wires on my head? There we go. That's the switch plate. Are you guys ready? Turn the power on, master switch on. Oh, it's noisy in here. Yeah, I'm sure they'd let me on a plane.